Most engineers know that Ethernet differential pairs are designed for a 100 ohm differential impedance, but far fewer stop to ask why that value is so important. The reason is that an Ethernet cable is no longer just a conductor connecting two devices. It's a transmission line governed by the physics of electromagnetic wave propagation. When the transmitter launches a signal into the cable, energy travels toward the receiver. If the signal encounters the same impedance at the end of the line as the characteristic impedance of the cable itself, the energy is absorbed and the signal propagates cleanly. However, if the load impedance doesn't match the characteristic impedance of the transmission line, part of the signal energy is reflected back toward the transmitter. In other words, an echo of the original signal is created, traveling in the opposite direction and interfering with subsequent data. For very short interconnects inside the device, these reflections are often negligible, but Ethernet was designed to operate over cable lengths of tens of meters. Under these conditions, reflected signals have enough time to travel back into the transmission path where they interfere with the desired signal. The result is degraded signal integrity, reduced data transmission quality, and a smaller noise margin. The situation becomes even more critical because Ethernet uses relatively low amplitude differential signaling. Even small reflections can significantly distort the waveform and degrade the eye diagram. That's why every part of the signal path, the PHY, the isolation magnetics, the RJ45 connector, the cable, and the PCB differential pairs, is designed to form a continuous 100 ohm differential transmission line. Maintaining impedance matching in Ethernet isn't just a design recommendation, it's a fundamental requirement for ensuring that signals propagate through the entire channel without reflections. At Ethernet frequencies, the cable is no longer just a piece of wire. It becomes a true high-frequency transmission line, and it must be treated accordingly. If you found this video useful, give it a like, subscribe to the channel, and check out our other videos on electronics design and hardware engineering.